Okay, welcome back. Now I'm back with that molecule that I left you all with to figure out the various major and minor products. Okay, now this time I purposefully gave you all a condensed line structure over the conventional full skeletal structures that you're familiar with. But people in my class are probably already very familiar with the condensed line structures. So let's get started. All right, so if you redraw the structure, again, I don't want to work out every single possibility, but I'll try to work out a few so you kind of get the idea on what's happening. Okay, now if you remember, this carbon has one hydrogen, right? This carbon has none. What is the basic foundational thing that we learned in our very first class? A carbon must have 4 bonds, okay? If there's a bond that needs to be added, that has to be hydrogen. This is already full. Now keep in mind, this is all CH3s, right? Whenever a bond is at the end, it has to be a CH3, right? So we have CH3s. Now again, when I do the same compound in different, when I try to figure out different products, I am not going to write this because it is understood. That's what I'm referring to. This one has 2 hydrogens. This one has 1 hydrogen, and this is the methyl group E. Right? Now, what is our stability sequence? Let's write that down. Okay, the stability sequence is your tertiary, okay, free radical, okay, I'm going to call it FR, is more stable than a secondary free radical, which is greater than a primary free radical, which is all in turn more stable than a methyl free radical, right? And you've looked at what are these different free radicals in the last 2 videos. So if you haven't still understood how to identify something as a tertiary, secondary, primary, or a methyl free radical, then I think you have to go watch the previous 2 videos, okay? So obviously, we know our tertiary free radical is the most stable. So that means we go look for carbons that would lead us to a tertiary free radical. And that means we should, when a hydrogen is gone, we should have a carbon with 3 different groups and no hydrogens left, right? So there's only 2 candidates that could give us that. One of them is this, and the other is this, right? Because you must have a hydrogen for it to happen, okay? This right here doesn't even have a hydrogen. So, and then, so let's go now work it out, all right? So I've now identified the tertiary for you. So let's get straight to the chase. So, okay. So I think my blue just got a little lighter blue. So I'm going to redraw this, okay? Focus only on this right here, okay? So this means there is this hydrogen with the connected to this carbon through the 2 electrons. So the Cl dot would then attack that hydrogen, right? Now keep in mind, it takes a little bit of time to get visually understand this problem, okay? So this connects with this free electron, lead us to our intermediate. Now again, on a multiple choice test, you wouldn't have to do all this, but on a descriptive portion of the test, I would expect that you show the actual mechanism, right? Okay. So here we are, and that's our intermediate, right? Plus, we've made HCl, right? Now keep in mind, again, the free radical, if a tertiary free radical has to be generated, that carbon must have only 1 hydrogen and 3 different groups, okay? That is well, that's basically a tertiary carbon, okay? That's what leads to a tertiary free radical. So now we have this. Now let's go get our second. Keep in mind, every time you break a Cl2, you generate 2 Cl dots. Okay, that's period. So let's go get our red color again. So this now combines with this, leads us to one of the major products in this reaction, which would be Cl gets attached here, the remainder stays the same, and then that's one of the products, right? Now we can also have, a product here, and then we also have a, if a carbon contains two hydrogens, then it is a secondary carbon because it has to lose one hydrogen to generate. So let's try that one. Let's pick this one right here. Okay. So if I do that part math there for you, I mean do the workout for you on this. Okay. So this has two hydrogens, right? Let's draw one of them with the two electrons, right? So the Cl dot would now react with either of the hydrogens. Okay, you don't need to get obsessed whether it should be on the right hydrogen or left hydrogen. Well, it doesn't matter, they're identical. Okay, this reacts with this free electron, leads to our first intermediate, which would be right. This is one of the hydrogens. I'm just going to leave it there, and there's a free radical now right over here. Right, now this combines with the other chlorine radical, lead up to this. It's too big. Okay, that leads us to the other product. Now what is this? This is a secondary free radical, right? That is a carbon with at least one hydrogen in three different groups and then a radical, right? So that would be, at least if not the major product, would be intermediate product between, right? That's how you do it. So that's one of the products. This is probably one of the major products, and then you also will have, this will be another major product because that can also lead to a tertiary free radical. This led to a secondary free radical right here. This is a secondary free radical. This right here is a tertiary free radical. And then you can also have plenty of, but if you do one, that's good enough. You can do, this is, you're starting with, if you take one hydrogen to generate a radical, that would be primary, 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 primary. So you can draw one of the 5 things that's possible, and that will be the minor product, right? And again, we cannot have ever a methyl free radical unless the starting compound is methane, okay, which we've already done. So from now on, it's mostly these 3 things which we will focus on, and I'm going to underline that in a different color. Okay, so rarely you will come across a methyl free radical in a compound like this. Methyl free radical is only possible for, so this will be a minor, intermediate minor. So let me just say intermediate minor, and then you'll also have minor, and explain how you can do it. Okay, if you can generate a primary free radical, which is a carbon with 2 hydrogens and another group, and then a free radical that is an odd electron, would lead to the minor product, and which would be, all this could potentially lead to a primary free radical. Why don't you go try that yourself, and if you have questions, post on the comments box. Otherwise, this is how you do a sequence of free radical reactions for alkanes. Now, the next set of videos we would learn would not be alkane, but it would actually involve an alkene, the one with a double bond, and how we can add a compound containing an halogen, such as a HBr or HCl, to, or even chlorine, to a compound that contains a double bond. All right, so stay tuned for more videos. Take care.